Thank you very much for joining us. The anticipation of why LLM hallucinations are great for you, I guarantee you it'll be worth the wait. So I'm Lisa Aguilar. I am the VP of our product solutions and our industry field CTOs at DataRobot, working with our industry teams to help organizations understand where and how to apply AI in the organization in very meaningful ways.
And my name is Justin Swansburg. Nice to meet everyone. I am the VP of our applied AI and data science practice. So I help to manage and run the team of data scientists, architects, and engineers that actually get to work really closely with our customers, delivering both predictive and generative solutions out in the field.
All right, so before we begin, a little bit about DataRobot. So who are we? We are a pure play AI platform. We've been in the industry for over a decade. We work with some of the biggest and largest brands around the entire world. We're doing a lot of things in terms of helping them embed AI into their business fabric. So everything from 1/3 of foreign exchange actually goes through DataRobot to actually working with government agencies and helping them detect and prevent drug trafficking, as well as helping with vaccine trials during COVID. And of course, we also help with meaningful AI applications across organizations. I think the biggest thing to note about DataRobot is we really are here because of our customers, so we are always honored and welcome to be seen as their data science machine learning platform of choice by Gartner Peer Insights. So what is it that DataRobot actually does? We are a unified system of intelligence. Think of us sitting between your systems of record, your data layers, and your business fabric where your business team actually sits. So most of you probably have more than one data warehouse. You have multiple applications in which you need to get to. So DataRobot, think of it as an enterprise-grade AI application pipelining for you. And how we do it is we really help bring all of your teams and processes together. So we help extend your Databricks investment out to all of the people who actually need to be able to access it, but they all may not be technical enough to be able to make meaningful value out of it. So what we do is think of us as an interface layer on top of Databricks. We give every single one of your AI creators, AI operators, the interaction and the UX that they want to be able to interact with. And the biggest thing that we do is we focus on project pass-through, because the biggest blocker for most AI applications is actually getting from the creation to the operations to the actual consumers. And we've streamlined this down. So most of the DataRobot customers can actually build and implement their ML and GenAI projects in 2 to 4 weeks, which means when the business comes to you and asks you for a project, you can deliver them a result within quarter to impact their business in a quarter, independent of as opposed to the normal time, which is about 11 months to actually build and produce machine learning models and get them into production, which is a year later, so your business has actually moved on. So how do we extend your Databricks investment? So one of the ways that we do that is we focus on helping you create predictive and generative AI applications that can actually be put into production. So when it comes to predictive aspects, you can take all of the advantage of the rich data and insights that are available inside of your Databricks platform. We do things like actually helping you secure your data connections. We do everything about push-down ML prep and actual feature discovery inside of your Databricks investments there. Of course, we have batch predictions and writebacks and scoring code integrations as part of that. Now, once you have your predictive insights and you want to embed them in your generative AI applications, you usually have to jump through hoops. DataRobot makes it very easy and seamless to pass that through. So when it comes to generative, once again, we're helping you take advantage of your Databricks investment. So you heard some of this in the keynote today, LLM prompting, how do I take care of that mosaic vector search and bring that in so it's much more accessible to a broader set of users. This is where DataRobot comes in. You can go ahead and bring that in with the LLM versions and mosaic. You can bring those in, but DataRobot focuses on something slightly different. We help you evaluate and benchmark and compare your agent workflows and your RAG models. So this is the augmentation. Justin's going to go into a little bit of details here to make sure that you're feeling really good about the applications that you're going to be producing. We also offer RAG synthetic data creation to help you evaluate and benchmark your solutions that you're creating, as well as a full pre-built library of intervention and moderations. We saw that in the keynote earlier today as well. How do you prevent it? You saw a little bit about DataRobot will actually be traced back, but you don't want to just trace back. You want to stop it in real time. And then, of course, we have the QA hosting back for feedback. Now, it comes to AI app deployment and actual management. We look at this a little bit different. We're really about governing all of your AI applications across organizations. We don't care where, who, or how they're built. You want to build it on DataRobot platform? Great. You have customers that are trying to build it inside of different notebooks inside of your organization. That's fine too. What we help them all do is register all of the apps that have been created, register any ML model that's been created, and register any RAG or agent workflow that has ever been created to give you a single source of truth. And of course, we have real-time intervention and moderation. So it's not about detecting and it's not about just looking to prevent hallucinations, but it's detecting them in real time and preventing them. Of course, we have prompt tracing, but we also have different insights. So generative AI topic drift is the information that your users want, different than how you built your model. And of course, we offer AI observability across all of your machine learning and your generative AI ecosystem. So you have real-time intervention, notification policies, so that you're not having to discover information passively, but it's being surfaced up to you when it's time for you to take a look at things. And of course, you can deploy any of these models directly inside of inside of Databricks, and make sure that you're making that investment. So Databricks and DataRobot, what's the value of this together? It's really about getting you to get AI into every single aspect of your business fabric as easy as possible. And the way that we do that with these enterprise-grade, very scalable, very repeatable pipelines for you to be able to do that efficiently and easily without having to custom code and rebuild them every single time. We do that through unifying your entire landscape, so all the best-in-breed components that Databricks has to offer, bringing them all together for you, making sure that everybody can collaborate on the applications together. That's the biggest key here. So getting it from when you're developing it to your business users, and then once your business users are actually using it, making sure that it's staying on topic for them. And of course, we do this all through simplifying the AI operations of building those pipelines. So hallucinations are great. I'm sure you're all saying how our hallucinations are great. And I promise you, Justin and I, we talk about this all the time, but they really are good for you. And I'm hoping by the end of this, we are going to convince you why hallucinations are actually great. So just making sure, and this maybe, you may already know this, but I just want to make sure we're level setting on everything. LLMs are really just guessing. They don't really know what the next word is going to be. They're doing this based on a probability. They're assuming that their next word is going to be based on what they're seeing. And hallucinations occur, and they're going to always occur because a large language model is designed to give you an answer. It's not designed to give you the correct answer. It's designed to give you a response. And so, of course, it's like a little kid. If you ask it something, it's going to tell you a story. Now, whether you believe that story or not. And it's not deliberate, just like a child. But it's just their inability to really distinguish what's false in its training, just like a little kid. Some hallucinations can be really quite obvious. So this is a fun one. We asked it, what's the world record for crossing the English Channel entirely on foot? Of course, it gives us an entire story about that. It says that it gives us an actual person, the time it took, and then it prompts us and tells us it's very dangerous to cross the English Channel on foot. We know you cannot cross the English Channel on foot, it's water. But hallucinations can be not so obvious as well. So this is a prompt that Justin actually did. He made up a data science algorithm here. And he asked it to compare the two and explain the benefits against each one of it. And it gave an actual response. And then he asked it, give me the code to implement this. So it actually wrote Python code for this very fake algorithm that does not exist. So we all know the saying, all models are wrong, some are useful. What we need to start embracing is the fact that all LLMs hallucinate. Some of those hallucinations are actually useful though. So we'll talk about why those are. So let me pass this on to Justin to dig in deeper.
Perfect. All right. Thank you, Lisa. I want to start by just introducing this concept around how we can actually leverage hallucinations to improve all of our production systems. And there's a few points that I want to make. First, and this one is relatively straightforward, all of these language models are eventually at some point going to hallucinate. In fact, to a large extent, they were designed to. They are creating entirely new content. So as practitioners or builders, if we don't actually capture during testing all the different ways that these models can and will hallucinate, then we can't possibly catch them or detect them, and most importantly, prevent them when our model moves to production. So that's the first big key here. We actually need to make sure that we're monitoring during the build phase all these different types of errors, and we're going to use the errors to learn the types of problems we need to look out for once our model is actually promoted to the real world and we've got actual users engaging with it. The second piece here is there are different types of hallucinations. I'll actually go through these 4 different categories here in a little bit. The reason, though, I wanted to spell them out on the slide is that the actual way in which you deal with the hallucination depends on the type. So we're going to introduce this idea of guard or audit models. Think of these like a security system for your home that can actually monitor your language model and catch any of these types of issues. The problem, though, is you need a specific type of guard model depending on the type of hallucination that your language model is actually prone to output. The second thing here that's really important is that there's this inherent trade-off between your model's ability or propensity to create a hallucination and the effectiveness of the model. So one example that I actually want to talk through here, we do quite frequently with our customers, that you actually heard in the keynote this morning, is leveraging Gen AI to create some hyper-personalized email campaigns. Obviously, you want these to be fairly creative. You want them to capture your customer's attention. So you've got to turn up that degree of creativity and actually encourage your model to come up with entirely new text that might entice your customers. And I'm sure everyone here, they've got their inboxes flooded with all these different DMs and marketing outreach offers. A lot of them are pretty plain vanilla, right? You really have no desire whatsoever to click on them. We need to use generative AI and its unique ability to create new, interesting content to actually solve that problem. But at the same time, the more you encourage the model to be creative, the more likely it is to invent things that actually fall into one of those 4 hallucination categories. So in our example here, we're creating entirely new text as part of a hyper-personalized email campaign. It does a really good job of personalizing the email copy and create something that a user would want to click on. The problem, though, is you introduce the ability now for this model to invent offers that your company actually doesn't sell. In fact, one of my favorite failure modes here is language models introducing placeholders. So has anyone here, by show of hands, I'm going to put you all to work, been on LinkedIn and been on your email provider and gotten an email where whoever sent it to you actually forgot to include your first name or the value prop? Hi, insert name here. It turns out the language models do the same thing. Despite the instructions you might provide and how explicit you are to fill in information, even the newest models, OpenAI GPT-4, 4 Turbo, Anthropic's Claude 3, will still occasionally leave these placeholders. And that is a form of hallucination. It is actually directly conflicting with the system instructions you provided. So you need a separate guard to actually catch that in production. And the whole thesis here, what Lisa and I want to convince all of you, is that the whole industry actually has been considering or looking at this problem the wrong way. There has been a huge focus on the effectiveness of language models, and everyone is providing benchmarks. There is a litany of issues with these benchmarks. They're biased, they are overfit to problems that your model won't actually see in production. But the biggest problem is what I mentioned earlier. These models are designed to be creative and output entirely new things. That doesn't necessarily mean it's a problem, but there's this inherent tension between what they create and then the ability to leak in some false information that you want to catch. So what we would propose and what we recommend and help our customers with at DataRobot is actually setting up a system of guards, a safety blanket, if you will, that actually works on the language model's output. So you don't stymie the model's creativity, you don't discourage it from creating new text, but you carefully monitor the output to actually catch these different types of hallucinations. In fact, I mentioned that there's this industry of benchmarking language models. You probably see charts like this quite a bit. Every time a language model provider creates or releases a new version, they tend to benchmark its performance. And off here on the y-axis, there's a bunch of different ways and benchmark data sets to detect or to evaluate the likelihood that a language model will hallucinate. And again, what we would argue is that you shouldn't test or evaluate the model's ability to prevent hallucinations. Instead, you should set up a monitoring and intervention platform that will try to catch these or intercept them in real time. So don't limit the model, the language model, add an additional model or check after the fact to catch the types of errors that you identified earlier during the testing process. And here, this is actually a screen from the DataRobot platform, where you can see we track things like hallucination incidents, confidence that we can mitigate or moderate, and even user feedback. And you saw during the keynote with Databricks, they released the ability to collect or solicit feedback. We can use that to train a guard model to anticipate the user's reaction and actually catch that before an answer makes its way back to the user. Now, what does the real framework look like if we zoom out a bit? Our definition of the correct way, if you will. It actually requires what we call multiple lines of defense. And the reason is there's no single silver bullet to capture all these different failure modes. The key is that you need to actually collect information on the hallucinations your model is prone to make, and then set up specific guards to detect them. They can be rules-based guards. They can actually be predictive models, which is a unique way to look at it. And of course, there can be language models. So you've got Gen AI, in a sense, babysitting your Gen AI. And it's actually quite effective. I told you I'd get back to the different hallucination types, and we're going to walk through a few real-world examples as well. I know Lisa shared some earlier. There are 4, though. There's input conflicting, context conflicting, fact conflicting, which is the most common. This is when it invents a truth that is technically incorrect. And then there is forced. And for all of these, DataRobot has a guardrail or a safety check, if you will, a screening filter to catch these particular types of errors in production. And the idea is that you stand these up or attach them to your pipeline. So you can see here, squished in the middle, almost like a sandwich, we have our actual language model or our RAG pipeline. And then kitty-cornered or bookend on both sides, we have those guards that are either running against the prompt or the response. So we can detect all these issues and then importantly, moderate them. We can actually block those responses in real time. So what this looks like from an architecture point of view, this is an overview or outline of a standard RAG process. User asks a question, it runs through the language model, it might pull in grounding data or context from a vector database and responds with an answer. You can imagine if we're in the world of finance, one of our larger markets, someone asks about the cost to open up a new savings account. Well, one type of hallucination here is just providing a factually wrong answer. This could be outdated. Maybe the bank introduced a new pricing model. Our models can actually help detect that based on the grounding data. It'll alert you that there's a hallucination and then jump in and actually moderate it in real time so that answer doesn't make its way back to your customer. Another example here is input conflicting. So let's say one of your users asks about overdraft fees. The model could give you a technically correct answer. You can see here it's responding about ATM fees, but that is not the answer to the user's question. And again, we've got separate guard models customized for this type of hallucination. And the whole idea here is you can't customize these if you don't have actual examples of how the model hallucinates and the type of hallucinations it produces. Once you collect those during training, and this is why hallucinations are helpful, you can custom build these guardrails to prevent them in production. The last thing here is this library. So DataRobot offers a gallery of a bunch of different ways to attach these guard models. We bucket them into 4 categories. There's cost, safety, quality, and correctness. And there's a bunch of research getting pumped into this field around building better, and more focused models that actually help detect really hyper-specific problems your language model can encounter. So we offer all of these out of the box, as well as the ability for you to further customize them once you start collecting data during your build process. And once this step is done, you actually have the ability in the UI to come in and then decide whether you want to just report and collect alerts around these guards, or actually what we call moderate it. And this is the most unique value prop with DataRobot. We can jump in, intercept these responses in transit, and then actually block or customize the response so that erroneous or incorrect data doesn't make its way back to your customer. Then the very last piece I want to highlight here, just to wrap us up, is how you go about collecting this data and understanding the types of hallucinations and the probability rate before you move your model into production. It's just like predictive AI. We set aside a holdout, some unseen data, and we use that to evaluate how well our model will perform in the real world. The difference is that we don't have the data to begin with in the generative AI example. So in DataRobot, you can actually create synthetic data. If you go back to the email case, we can create a whole bunch of example emails. We can run our guard models against those to get objective information about the assessment or quality of the emails, and then use that information to build or further customize our guards. So we're gonna use the synthetic data generation technique to build the training data set we need to then build out this guard framework and better understand all the different scenarios in which our model goes off the rails. And once this is done, you actually have a clean UI with real-time alerting inside the DataRobot platform that will warn you when these hallucinations do occur and let you actually double-click into a full trace to understand what prompts led to the hallucination, what the actual incorrect or hallucination was, and then let you modify or moderate it from there. So there's always this human in the loop aspect. And then finally, just to wrap what we heard and close here, there's really 3 bullets that I want to emphasize. And the first one is that hallucinations are inevitable. You can try and minimize them, and you can try and fine-tune your language models, but the truth is, the way they were built, the underlying architecture, is actually encouraging hallucinations, because at the end of the day, these models do need to make up entirely net new information. So what do you do knowing this? Well, you focus on this agent testing or workflow that'll actually come up with and produce examples of how your model may go wrong, the types of hallucinations it'll prevent, and then you use that to build these guard models that will work for you in real time to prevent these. So it's a combination of your language model and your guard model. With that, that is a wrap. We are actually at the booth right around the corner, booth number 37. So please check us out, come by if you want a demo of all of this, and feel free to scan this QR code here. We have another speech going on about choosing the right language model, and you'll find all the information if you just take out your phone and scan that. So with that, thank you. Appreciate you all coming here. Lisa and I will hang out and answer any questions.